In this video, we are going to talk about the law of conservation of mass uh, in terms of how it translates to the chemical equations and chemical reactions that we have discussed in the previous videos. So first, let's take a look at this equation. So you have water, which is in liquid state, and you let electricity pass through it, and it will decompose into hydrogen gas and oxygen gas. But here there's a problem, because if you look at the number of hydrogen gas on the reactant side, or hydrogen atoms in the reactant side, there are two hydrogen atoms, right? See, H2, and there's one oxygen atom. But on the product side, there is two hydrogen atoms and two oxygen atoms. Okay, so what does this imply? Well, this implies that you had water, and then when it decomposed, you produced hydrogen gas and oxygen gas. That means you've created another oxygen atom, right? So it's just like magic. There was one oxygen atom in the reactant side, and all of a sudden you produce two oxygen atoms in the product side. So it's magic. And again, science class is not magic, so therefore this is wrong. This is wrong. So how do we resolve that then? How do we create a process that would correct for that? So what you see above and also what you see below is an example of an unbalanced chemical equation. So remember, we've discussed about chemical equations, how to write them, but we did not really delve into what is an unbalanced and a balanced chemical equation. So this is an unbalanced chemical reaction because, again, if you look at the reactant side, you have two iron atoms, three oxygen atoms, and one carbon atom. But on the product side, you have one iron atom, one carbon atom, and two oxygen atoms. So it seems like we have a missing iron atom and we have a missing oxygen atom. So again, it's not like that. Everything must be conserved. Meaning, if I have 1 kilogram of I don't know, ingredient A and 1 kilogram of ingredient B, when I mix them, if I don't lose anything, it should be 2 kilograms, right? You should not lose anything. You should not gain anything. That is the essence of the conservation of mass. Remember, the conservation of mass says that the mass before and the mass after must be equal. So in other words, you cannot create or destroy matter, because remember, mass is the measure of matter, how much matter there is. So therefore, this is wrong because you have created an extra oxygen. This is wrong because you destroyed one iron and one oxygen. It's missing. So again, to resolve that, but first we have to remember that this is the most fundamental law. During a chemical reaction, the total mass and number of atoms of reactants equals the total mass and number of the atoms of the products. So therefore, there should be no missing atoms whatsoever. So you have here a balanced equation. So look at the balanced equation. So this is now in contrast to the previous two equations. This is a balanced equation. So if you look at the carbon, there's one carbon, 4 hydrogens, and 4 oxygens. And how does this work? Because again, remember our discussion about coefficients? 2O2 means there are 2 molecules of O2. So if each molecule is 2 oxygen, and there are 2 molecules of that, there must be 4. So you multiply this subscript with the coefficient. So 2 times 2 is 4, right? And then on the other side, you have carbon, which is 1. And then you have oxygen, you have hydrogen, which is 2, because remember, you have to multiply the subscript with the coefficient. So 2 times 2, that's 4. And then the oxygen, you have 4 because you have 2 places. Here on this side, sorry, here on this side, that contributes 2 oxygens. And then this side contributes another 2 oxygens. And you might say, why is it 2 oxygens, sir? This is just 1 oxygen. Remember, subscript times coefficient. So 1 times 2 is 2. So you have 2 oxygens here, and you have 2 oxygens here. Okay? So in other words, how did we balance this? How did we balance this equation? If you look at that, we change the coefficient. See? This one. The coefficient. It's the important part. The coefficient. Okay? So, that is a balanced chemical equation. And so now, how do we determine if it's balanced or not? Well, we create what we call an accounting table, just like what you saw in the previous one, where we count the number of each atom in the reactant side and the product side. So for example, here, this one, 8 sulfur and 2 oxygen, and then 1 sulfur and 0 and 3 oxygen. So it's not a balanced equation, it's an unbalanced equation. Example 2, there is 2 hydrogen, there is 2 nitrogen and 6 hydrogen, because remember, subscript times coefficient. 2 times 3 is 6. And then on this side, that subscript is 1 here, understood to be 1. 1 times 2 is 2, and then 3 times 2 is 6. So in this case, this is a balanced equation because, well, it's balanced. The equal number of things. And then here, I just want to discuss how to deal with coefficients and subscripts. Although we have discussed this before, the first video. But again, I want you to understand that if you have 2 NH3, it means there are 2 molecules of NH3. Okay? So, for example, so how you deal with that is, if you count the number of H, right? If you count the number of H, you have to get the subscript, 3, and the coefficient of the whole molecule, multiply them together and make it 6, right? And again, when I was in high school, I just blindly followed this, okay? Just subscript with coefficient, multiply it. But I want you to really have a deeper understanding, because why this works, multiplying these two works, it works because, think about it, if you have 2 NH3, it means you have 2 molecules of NH3. This is molecule number 1 and molecule number 2. And that is what NH3 is. 1 N with 3 H's, right? So you have 2 molecules because you have 2 NH3. So if you count now the number of H, how many is that? 1, 2, 3, 4, 5, 6. That's why this works. So what I want you to know, what I want you to really understand is this idea that this step, which is to multiply the subscript with the coefficient, it's not just there because it was invented. Because it really makes sense. Because, again, if you have 2 NH3, it means you have 2 molecules of NH3. If each molecule is 3H, and you have 2 of them, then naturally you will multiply 3 times 2, right, to get 6. Okay, so I want you to understand that, because that is kind of an important concept to digest. So here, how about the number of N? Well, there is 1 nitrogen in each molecule, and there are 2 molecules, so 1 times 2. So that's why you multiply the coefficient, the subscript with the coefficient. And again, mind you, even if there's no 1 here, even if the subscript here is absent, it's understood to be 1. When there's no subscript, it means the subscript is 1. How about multiple subscripts, sir? For example, here, Cu, open parenthesis, NO3, close parenthesis, 2. Then you still do the same. So you have 2, the outer subscript, the inner subscript, or the innermost subscript, times the outer subscript, times the coefficient. So you have 3 times 2 times 3 times 3 times 2 times 2 is 12. And then if you now count the nitrogen, again, the subscript of nitrogen, which is 1, inner subscript, the outer subscript, because N is under the parenthesis, which is 2, and then the coefficient, which is 2. Okay? And then take note here, for copper, you have only the subscript multiply with the coefficient. But why don't we multiply it with the outer subscript? Because again here, copper is not inside the parenthesis. And so it does not have multiple levels of subscripts. Remember, the parenthesis is only holds NO3 inside. Cu is not part of it. Okay. So again, let's check if this is correct. If you have CuNO3 2, what does that mean? Well, it looks like this. This is Cu. Let me just highlight this. This is Cu, right? And then this is NO3, right? So think about it. N with 3 oxygens, so that's NO3. NO3. But why is the NO3 uh, uh, inside the parenthesis with 2? Well, because there are two NO3s. One NO3, the second NO3. There are two NO3s connected to copper. So that's why the formula is Cu, copper, open parenthesis NO3, close parenthesis 2. Meaning, there are two NO3s connected to copper. So you see, first NO3, second NO3, both of them are connected to copper. Okay? Now let's check if this calculation was correct. So for example, what was the calculation, sir? The calculation was, if you have this 2CONO32, you have 12 oxygens. 12 oxygens. So let's check if that is correct. So first, remember the coefficient is 2. So therefore, I must have 2 of these. Not just 1, but 2. Right? So that's why you have this molecule here. This is the first CuNO32. This is the second CuNO32. And then let's count if it's really 12. Okay? So that's 1 oxygen, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You see? It is correct. So again, more than the procedure. And the procedure is, inner subscript multiplied by the outer subscript multiplied by the coefficient. Instead of, aside from memorizing that, understand why it works. And again, this is the reason why I've drawn it here, so that you understand that, okay, that makes sense. That's why there are 4 nitrogens. 1, 2, 3, 4. That's why there are 2 coppers. And remember here, how many oxygens? 12. How many nitrogens? 4. How many copper? 2. So it works, right? So that's how you deal with that. So now here you have this one. Again, another example. So sometimes you can have equations where an atom is found in 2 places. For example, here, NaNO3, oxygen is found only in 1 place here. But in the product side, you have NaNO2 and O2. So meaning the oxygen is found in 2 places, here and here. So what do you do in that case? You add. So for example, there's 1 sodium here. There's 1 nitrogen here. But for the oxygen, remember, see, I wrote it as 2 plus 2. Just to emphasize that this 2 comes from here. So subscript times coefficient, 2 times 1, that's 2. And then subscript times coefficient, 2 times 1, that's still 2. So again, it's an unbalanced equation. Here, it's balanced, so you can evaluate that on your own. So therefore, you can make an accounting table. So for example, number 4 and number 5, you can do this yourself. You can account for all the elements here and see if it's unbalanced or balanced. Okay? So for this lesson, I really just focused on the idea of there is what we call balanced equation and an unbalanced equation, and that they differ, and we should balance all unbalanced equations. But for this video, we are just focusing on how to determine if it is a balanced equation or an unbalanced equation. And then in the next video, we will probably discuss on how to balance things, how to balance an equation so that it is correct, right? Because An unbalanced equation is strictly a wrong equation.